Calorimeter. Structure of a calorimeter. A calorimeter is used to measure the heat content of an object. Using this equipment, we can measure the heat produced or absorbed in a physical process. Calorimeter is nothing but a cylindrical vessel made up of copper. To keep temperature of the mixture in the calorimeter, it is required to stir the mixture continuously. Therefore, a stirrer made up of copper is also used. Calorimeter vessel is kept in a wooden box. The box is covered with a lid. The lid has holes for a thermometer and a stirrer. Since calorimeter is kept in a wooden box, no heat exchange takes place between the mixture in the calorimeter and the surrounding. Also, there is cotton or felt present in the gap between the calorimeter and the wooden box. Thus, due to the wooden box, the calorimeter is isolated thermally from the surroundings. Uses of calorimeter. Water of constant temperature is poured in the calorimeter. The temperature of water and that of calorimeter is the same. If a hot object is dropped in the water present in the calorimeter, then heat is exchanged between the object, water, and the calorimeter. As a result, after some time, their temperature becomes equal. Since calorimeter is thermally isolated from the surroundings, heat given up by the hot object is equal to the total heat absorbed by the water and calorimeter. Similarly, if we drop a cold object instead of an hot object in the calorimeter, then the object will gain heat from the water and the calorimeter and its temperature will increase. As a result, the temperature of water and calorimeter will decrease. Suppose mc is the mass of calorimeter and T1 is its temperature. Let mw be the mass of water present in the calorimeter. Temperature of water will be the same as that of the calorimeter, that is T1. Now, we will drop an object of mass m0 and temperature T0 in the water present in the calorimeter. If T0 is greater than T1, then the object will give heat energy to water and calorimeter. As a result, all three will reach the same temperature after some time. Let Tf be the final temperature of water, calorimeter, and the object present in it. The heat given by the hot object Q0 is equal to the sum of heat gained by the water Qw and heat gained by the calorimeter Qc. Thus, Q0 is equal to Qw plus Qc. Now, Q0, Qw and Qc depend upon mass of the object, difference in the temperature, that is delta T, and specific heat of the object. Suppose specific heat of calorimeter, water, and the object are Cc, Cw, and C0 respectively, then Q0 is equal to m0 into delta T0 into C0. Here, delta T0 is equal to T0 minus Tf. Qw is equal to mw into delta Tw into Cw. In this case, delta Tw is equal to Tf minus T1. Qc is equal to mc into delta Tc into Cc. Here, delta Tc is equal to delta Tw, which is equal to Tf minus T1. Thus, m0 into delta T0 into C0 is equal to mw into delta Tw into Cw plus mc into delta Tc into Cc. In the above relation, we can measure all temperatures and masses. Also, we know the specific heat of the calorimeter and water, and then we can find the specific heat of the object.